Okay, so this is the key to Inequalities worksheet 2. So you had these absolute value inequalities, and you wanted to solve each of these absolute value inequalities. And notice it says show all required work, and then you're going to write the solution in interval notation. So let's go to the first one. So the first one is an absolute value less than inequality. The way you solve a less than inequality is going to be different than the way you solve a greater than absolute value inequality. So one is going to involve the word and the other is going to involve the word or. And, or. Okay, those words are important. When solving the less than inequality, that's going to be an and statement. So less than, and. That's going to be an and statement. And the way you're going to solve a less than inequality, there are two ways you could do it, but one way is this. So you're going to say 2x minus 1 is less than 5, and at the same time, 2x minus 1 has to be greater than a negative 5. Okay? Okay, so notice less than is an and statement. So you have, all I did here was rewrote this without the absolute value bars. So when you have an absolute value inequality and the absolute value bar is by itself, you want to then split it up into two inequalities. Here you need the word and. So notice one's less than, greater than, 5, opposite. The idea of opposite. Now we're going to come back and we're going to solve this, but let's go to the second one. The second one was this. So we have the absolute value of 3x plus 2 is greater than or equal to 1. Notice this is greater than, right? So that's going to be an or statement. So greater, think greater, or. That's going to be an or statement. So how does that look differently? Well, this is the way it looks differently. So once the absolute value bar is by itself, you're going to split it up like this. You're going to say 3x plus 2 is greater than or equal to 1. And now remember, this was and, right? This is going to be or. Or, and you're going to say 3x plus 2 is less than or equal to negative 1. So notice it looks similar, right? Less than, greater than equal to, less than equal to, 1, opposite. Difference is, this is and, this is or. Okay? All right, so remember, less than use an and statement, greater than use an or statement. And remember, and means intersection. Or means union. Or means union. Okay, now let's go back to number 1. So to solve this absolute value inequality, we're going to solve each of those individual linear inequalities. So I'm going to add 1 to both sides. So I get 2x is less than 6. Divide both sides by 2. I get x to be less than 3. Now remember, x is less than 3 is a solution to this. It may not be a solution to the original, to the absolute value. Okay, that's where that intersection comes in. Over here, we add 1 to both sides. So I get 2x is greater than negative 5 and 1's a negative 4. Divide both sides by 2. I get x to be greater than negative 2. And remember, any real number greater than negative 2 is a solution to this only. It may or may not be a solution to the original. That's where that intersection comes in. Okay, now let's talk about what the solution actually is. So we're going to graph each of these individually on the number line. And so here's, and make sure you put them in order. So negative 2 is going to be on the left, 3 is going to be on the right. And so x is less than 3. See, there's no equal sign, so you can put an open circle to the left. So all these numbers here that are shaded, any number less than 3 is a solution to this. X greater than negative 2, open circle, all numbers to the right. You want a greater than. Any real number here is a solution to this. But I want to find the solution to the absolute value inequality that's a less than. That's an and statement. So then the solution would be anything that overlaps. And so the only thing that overlaps would be negative 2, between negative 2 and 3. Don't forget the open circles. So anything shaded is a solution to the original. So in terms of interval notation, you're going to say parentheses negative 2 all the way to parentheses 3, and that's your solution. So your solution to the original will be any real number between negative 2 and 3. No other number works. For example, if you say 4, let's try 4. You see, 4 is not in here, right? 4 is not a solution then. So let's see why. 2 times 4 is 8. 8 minus 1 is 7. The absolute value of 7 is 7. Is 7 less than 5? No. But if you check any real number that's inside between negative 2 and 3, it will work. So for example, let's check 2. 2 is in here, right? 2 is between negative 2 and 3. 2 times 2 is 4. 4 minus 1 is 3. The absolute value of 3 is 3, and 3 is less than 5. All right, so less than, you're going to have to say the word and that's the intersection. So I needed to see the word and. I've mentioned this in those lessons. You have to show the word and. With the greater than, you had to show the word or. Or means union. So what that means is this. The solution to this absolute value inequality that's a greater than, in this case greater than equal to, will be the solutions here or the solutions here. Whatever the solution here is, it's a solution. Whatever the solution is here, it's a solution. So the solution here, because the union, you remember union means either here or here. Both of those will work. Over here, intersection means only where those two intersect will it be a solution. Here, union means the solutions here or the solutions here will be a solution to the original. So just like with the previous one, we're going to solve each one individually. So we're going to subtract 2 from both sides. So I get 3x is greater than or equal to 1 subtract 2 is a negative 1. Divide both sides by 3. I get x to be greater than or equal to negative 1/3. This is a solution to this, and it's also a solution to this because of the word union. So any number greater than negative 1/3 is going to be the solution to this. When we did this, any number less than 3 was not a solution to this because we need to look at the intersection. So that's why we had to do this. But here, since that's an or statement meaning union, that's a greater than, then once I solved this inequality, then I found solutions to this. But there's also some other solutions. The solutions to this is a solution to this as well. So let's look at that. So subtract 2 from both sides. I get 3x is less than or equal to negative 1 and a negative 2 is a negative 3. Divide both sides by 3. I get x to be less than or equal to negative 3 divided by 3 is a negative 1. So any real number less than or equal to negative 1 is a solution to this, and it's also a solution to this. So you may say, well, what does that look like on the number line? Well, on the number line, it looks like this. So let's do each one individually. Notice that negative 1 is to the left of negative 1/3. So make sure you put them in order. So when I graph this one, x is greater than or equal to negative 1/3. That's this. So any real number is a solution to this because this is a union, an or statement. X is less than negative 1 is this. So notice that any real number less than negative 1 is also a solution to this. So the solution to my original will be this. Well, how do you write this in interval notation? So that's what the graph looks like. How do you write an interval notation? You're going to say this. You go from left to right. So remember the left arrow and then right arrow. So left arrow means negative infinity. When you go to the right, it means positive infinity. So you're going from negative infinity to negative 1, parentheses, because there's no equals. Oops, sorry. This is a closed circle, right? I made the mistake because that was a equal sign. Okay, closed circle. So closed circle because the equal sign. All right, so that's going to be bracket right here. So that's a bracket. Union, so my solution involves two intervals. This interval and also this interval is a solution. So union and then bracket negative 1/3 to infinity. So that's your interval notation. So remember, when you deal with infinity, negative infinity, you always put parentheses. And we use brackets here because both of those were equal to, so closed circles. All right, so that's how you do an OR statement. So greater than is an OR statement, less than absolute value is an AND statement, intersection. Now, some students, I'm going to say this, some students see that number one's an AND statement, right? Number one's an AND statement. So you could have written it in compact form. Since this was an AND statement, you can write it in compact form. But that only works, so this would be approach number 2. That only works if this is an absolute value less than. You cannot do a compact statement with greater than. The only way you can do a absolute value greater than is to write it as an OR statement. But with an absolute value less than, you can do an AND statement like this, or you can write it like this. So look at what we have here. And I'm going to see if I can yeah. All right, so this right here. So 2x minus 1 is less than 5, right? And at the same time, this 2x minus 1 has to be what? It has to be greater than a negative 5, correct? It has to be greater than negative 5, meaning that this 2x minus 1 is less than 5, and at the same time 2x minus 1 has to be greater than negative 5. So with an AND statement with the less than, you can write as a compound statement like this. An OR statement you cannot. The only way to do a greater than is to do this. You cannot write it in this form. And then all you do is to get x by itself, and I want to show you that when you do that, you're going to get this right here. So you add 1 to all parts. Negative 5 plus 1 is negative 4. It's less than 2x. It's less than 5 and 1 is 6. Divide all parts by 2. Negative 4 divided by 2 is a negative 2. It's less than x, and that's less than 3. So you see right here, negative 2. So all my solutions are between negative 2 and 3, which is what this says. So in interval notation, you're going to say negative 2 parentheses because there's no equal sign, all the way to 3 with parentheses as well. All right, but keep in mind that the only reason why you can write it in this compact form here is because this was a less than absolute value. A greater than, you cannot. You cannot. All right, so that was it. So that was the key to Inequalities worksheet 2.